Today we are going to be taking our journey into the topic integration calculus. Remember, we have done limits, which is the basis of the course calculus, and we have done integration and differentiation calculus. Now today I'll be looking at general overview on integration calculus. Now I'll be doing the first part, how to integrate different functions we have. The second part is special integrations we have for different functions and so on. Now, what is the meaning of different integration? We said differentiation is the art of finding the derivative of a function. What about integration? Integration is also known as antiderivative. It's also known as what? Antiderivative. Integration is a branch of calculus that deals with the study of antiderivatives. How to something like check the reverse of differentiation. That's what we're looking at now. The reverse of differentiation. Integration is also known as what? Reverse of what? Differentiation. We have two forms of integration. We have the definite integration and we have the indefinite integration. Now, what's the meaning of definite integration? What's the meaning of indefinite integration? Now, for definite integration, you are going to sum up what you are doing within a definite range. It's a type of integration that have limits. Both we have upper or have the lower limit. Now, integration has this symbol. This symbol, we call it the integral sign. We call it the integral sign. You can see it looks like X, but it's not X. Now, for indefinite integral, the thing will take this shape, just the integral sign. But for definite integral, you have a limit here, let's say from B to A. B to A. So this time we are integrating any function that we get from B to A with respect to a particular variable that will be there. So I'm going to show this is definite integral, and this other one that just have this symbol is indefinite integral. You don't sum up, you just do it arbitrarily. You are not like looking at a particular spot. No, but this particular integration that we are summing up within a particular range from A to B. That's what we are doing. We are integrating within a particular range from A to what? To B. So take note of that. It's very, very important. So don't forget, we have two types of integration. We have the definite integration. We have the indefinite integration. Remember, definite integration is normally integrated within a particular limit or range. And also, we can also use this definite integration to find area under a particular curve. So if you find the area that is curve, we use a definite integration for that. While this indefinite integration don't have any upper or lower limit. Now let's look at the integration of different types of functions now. Let's start from polynomial functions. The first thing, polynomial functions. The polynomial function. How to find the integration, how to integrate polynomial functions. For example, now the general formula is that if I integrate x to the power n, let me put a here with respect to x, or I integrate a with respect to x, in the sense that a and n are constants, while x is the variable, what will be the final answer to this? What will be the final answer to this? So let's go with this first one. If I integrate a number times x raised to another number, I'm going to have that number times x raised to that number plus 1 all over the number plus 1. Then I'm going to add what I call plus c. Add plus c. And what is the meaning of this c? I will explain it. Then what about this? Okay, what is the meaning of this c? That c means we call it integration constant. And it's normally used when you are doing indefinite integration. After integrating the function, you must add a constant to it because there might be a constant. Now, this integration, this is the question. If you differentiate this question, you're going to have this. So what we are doing here, we are integrating answers from what you differentiated before. So when you differentiate a function, you're going to have an answer. If you integrate that answer, you will get back the question you differentiated before. So in case there was any constant you differentiated before that was 0, that's why we are putting plus c here. When you are doing indefinite integration, you add plus c after everything. What about I want to integrate a with respect to s? In the sense that there's no s here. Remember, if I differentiate a constant that don't have s, the answer will be 0. But if I integrate a constant that don't have this x, in which I'm integrating with respect to s, the answer will be that constant times the x. or times what you are integrating with respect to, which is a times s. What is that? Will be ax plus c. That is the answer. So when you integrate, for example, now let's say I integrate 3 dx. So what's the answer to this? This is a short way. I'm just doing shortcuts here. Everything I'm going to be doing here, we just shortcuts. That's all. I'm not doing long cuts here. So you get it. I'm doing shortcuts. So this is just a shortcuts. Now we create a constant. Let's say 3 now. There's no s here. We're going to be 3 times s, 3s plus c. Let's integrate 4 dx. What will be this? That will be 4x plus c. If I say integrate 6 dy, with respect to y, that will be 6y plus c. That's what I'm trying to say. You don't be this times anything that is here. If I say integrate 7 dw, that's what will be 7 times w, 7w plus c. That's what I'm trying to say. So if you do the constant, what is going to multiply here? Why am I integrating 6x plus 3, 6x squared plus 3s plus 1 respect to s? What will be the answer to this? The answer will be you integrate each of them respectively. That's what you do. You integrate each of them respectively. Remember, how do I integrate something that has power? If the s is having, if the unknown is having, or the variable is having power, remember how to do it. We add 1 to the power, we divide everything by that new power. If it's not having power, what you just do? If it's not even having power, if the power is 0, you just make a constant there. You don't constant to multiply the power. Remember this 3 now, this 3x, this s. Anytime you see x or a number standing, there's a power there, the power is 1. But they will not put it. So if I want to integrate one, I'm going to have something like 6s, I'll add 1 to this power, that is 2 plus 1. I'll divide by that 2 plus 1. Plus, if I want to integrate one, will be 3x, I'll add 1 to this power, I'll divide by that same power. Then plus 1, there's no s there. Remember I told you if you want to integrate anything about what do? You need to multiply the s. 1 times s, what's that? Will give us x plus c. This one is going to give us 6x power 3 over 3 plus 3x power 2 over 2 plus x plus c. So we are going to be using shortcuts. Remember, so I'm just using this one now so that you just get it. Well, I've already done a topic which is integration calculus, division of polynomial functions. I'll go and check it before coming back to this. But just ask questions. I'm just going to be solving questions here, questions, using shortcuts and all possible methods, very fast approach. So we're going to have 3 into 6, we now have 2. Okay, that will give us 2s cubed plus 3 over 2s squared plus x plus c. That will be the final answer. So let's say we are doing this, integral 3s plus 1 dx. What will be down to this? Yes, that will be what? On the 3s what? Square over 2 plus what? X plus c. That's all. Try to do that yourself. Then let's say we want to do integrating 7s squared plus 6 dx. What is the answer to this? The answer becomes 7s power 3 over 3 plus 6x plus c. Answer. I hope you got that. I hope you got it too. So let's say we want to do something like this. Let's say we want to do integrating 6yx. Okay? Let me just say 6y dx. What will be the answer to this? In which s is the only variable there. Whatever you have. If I integrate something like this, when s is the variable, that's how big you have s here. Check. Is there any s here? There's no s there. I told you if you integrate anything that don't have s, what do you do? Use that stuff to multiply the s. That becomes the answer. So 6y times s, that gives us 6yx plus c. That will be the answer. 6yx plus what? Plus c. The take of that is very important. If you change this one, let me see, it says that only s is the constant. We change this s, we have 6y, we change this one 0. That's what we are trying to say. So in the same way, if you have 6a dx, and see what is the integration? If you integrate something like this one, that's how big 6a times s, what is that? 6as plus c. That's what I'm going to have. So now let's look at more questions on that. Let's go integrating 3s squared plus 2s plus 8 with respect to x. What will be the answer to the 3s squared plus 2x plus 8? What will be the answer to this? Does that become what? What will be the answer? Try and do this yourself. Try and do this. Does that become? You want to solve with your eye? Just do it. 2 plus 1, that is 3. 3 divided by 3, that is 3 cancel 3. We are going to have s cubed plus, okay, this one is 1 as power. 1 plus 1, that is 2. Divided by 2, 2 we cancel 2. that will be s raised to power 2. You know what I'm saying? Plus a times s, because a don't have x, that's 8x plus c. That's how you solve it in the exam condition. You just solve it to add. Add on to this one now. Look at what you're going to have 3. We're going to have 3s raised to power 3 over 3 plus 2s raised to power 2 over 2. Remember, you'll be adding 1 to the power. Plus this one don't have s, we need to multiply x. So 3s raised to power 3 over 3, 3 will cancel 3. 2s raised to power 2 over 2, 2 will cancel 2. 8 times s will give us 8x. That's all. R plus c. R plus c. So let's solve more questions. Integral 7 x plus 8 dx. So this one is going to give us what? 7s squared over 2 plus 8x plus c. Let's say we have 4s cubed plus 3s squared plus 6x plus 11 dx with respect to x. When you with respect to s, that will give us, what am I going to have 4s power 3 plus 3. That's 3 plus 1. That's 4s power 4 over 4 plus 3s power 3 over 3 plus 6s power 2 over 2 plus 11s plus c. So this one give us, we'll cancel 4, s4 plus, now cancel this, s cubed plus, this one here, 3s squared plus 11s plus c. Answer. So this is how you integrate polynomial functions. Now, let's look at how to do exponential functions. Let's look at how to integrate exponential functions. Let's look at how to integrate exponential functions. Now, to integrate exponential functions, you have to just know the rule. That is all. This rule we did here, that rule which you have 1 to the power divided by the new power, that is only for polynomial function. Now, when we get to exponential function, we also use the rule for exponential functions. I'm going to be showing you 3 rules for exponential functions. He said that you have to follow up with the rules. That is all. Just know the rule and you are good to go. Now, we have exponential function of this exponential x dx. You have exponential function of this a raised to power x dx. You have exponential function of this a raised to power px dx. So what will be their respective answers? So these are the 3 exponential functions we are going to have in this class. So if e is the base, the answer will still be exponential x plus c. But if you have exponential a raised to power x, that the base is not e, it's now a number. Let's say 3 raised to power s, 10 raised to power s, a constant over raised to power s. That's how it becomes that question divided by log of the base to base e plus c. You can also take in of the base plus c. Remember log to base e, set it as ln, something like this. Something like this, ln. Then, what about if it's like this? You say you write the question out raised to power px over this p times log of the base to base e plus c. Now let's say we have something like this. Integrate exponential 3x dx. What will be the answer? That's how we become exponential 3x plus c. But the reason why that will not become the final answer is because, look at it, because what we have here is x. What we have here is 3s, not x. So what we will now do to this 3s? We will differentiate 3s. Differentiate 3s, what is the answer? 3. Divide the answer by that 3. That will be the final answer. So if I say integrate exponential 8x dx, what will we say the answer is? That's how it comes. Exponential 8x over 8 plus c. How do we get this 8? Differentiate 8s, you have that 8. That's all. So let's say if you integrating exponential 10 minus 21x. What is the answer? 10 minus 21x. That will be exponential 10 minus 21x over differentiate 10, 0. Differentiate minus 21x, that gives us minus 21 plus c. This minus should be here, not to be with the denominator. That will be the final answer. So what about we have to integrate exponential 11s plus 2 dx? What will be the answer? The answer becomes what? Exponential 11x plus 2 over 11 plus c. That is the answer. So please, show you know what we are doing. What about exponential 3 raised to power s dx? What am I going to have there? If you have to do like this, remember this word. A raised to power s divided by log a to base e. What is a there now? A is 3, check. A, 3. So I'm going to have 3 raised power s all over what? 3, okay, no. Log 3 to base e plus c. A raised power s all over log a to base e plus c. So if I said I have integral 4 raised power s ds, I can also write as what? 4 raised power what? S all over what? In 4 plus c. Remember, in and log to base e are the same. So let's have it like this. Integral 6 raised power x dx. What will you say the answer is? The answer will be 6 raised power x over what? In 6 plus e. That is plus c. What if I have integral 7 raised power 2x dx? What will you say the answer is? Integral 7 raised power 2x dx. What will you say the answer is? The answer becomes 7 raised power what? 2x. Check. This question now, is it from, no, it's not from, because the base is not e. The first place. Then let's check it from here or here. Check now, we have just s here. For that one, we have 2s. So this one is going from ps, this third one. Remember the log. E raised power ps over p log a to be c plus c. So I'm going to have a here 7, p is 2, all over p log a to be c plus c. So let's say we have integral 6 raised power 3x dx. What becomes the answer? To be 6 raised power 3x over what? 3 log what? 6 to base e plus c. Answer. You are just writing question answer. This is how you roll in calculus. This is how you roll. If you know you are doing that, this is how you roll. So we're going to have integral. Let's see. H raised power 2x dx. What becomes the answer? The answer becomes h raised power 2x over 2 log what? 8. 2 log 8 plus c. You don't have to be e. To be still. That. Now let's say we have integral 20 raised power minus 3x to dx. What will be the answer to this? The answer is not far from 20 raised power minus 3x over, what you have to differentiate this minus 3, that will be minus 3 log 20 to base e plus c. That becomes the answer. That becomes the answer. So this minus will just come here. But if you differentiate 20 minus 3, yes, you're going to have minus 3. So that's what you're going to have. That's what you're going to have. You still integrate this. If you differentiate on back now, you're going to have that question back. So let's go. The next thing I'm going to have now, let's say we have this question integral 40 raised power 3x. 40 raised power 3x. What becomes the answer? The answer becomes what? How we can do that? Let's say we have integral 10 raised power x ds. How we can do this? Let's say we have integral 2 raised power 4x to ds. How we can do this as well? So what becomes the respective answers? And now this is what? 40 raised power 3x over what? Over 3 in 40 or log 40 to base e plus c. So give us 10 raised power x over in 10 plus c, because there's nothing here to put at the back of this place. So give us 2 raised power 4s, 2 raised power 4x over 4 in 2 plus c. That is all. The question is very, very, very simple. So it's either you use log to base e in this place of ln, or you use in, as in there. So take note, log to base e simply as this symbol and then is take note of that. It's very, very, very important. So this is how you run through exponential functions. Now let's look at function of a function. Let's look at function of a linear function. Let's look at having functions, linear function, and also let's look at logarithmic functions. Let's look at logarithmic functions to see how to integrate those stuffs. It's a very sweet thing to do, and it's very nice if we know how to do them, if we know how to run through them. Then let's go. Let's go at that. So what we're doing here now is to look at something like this integration of this 5 mx plus c raised to power n dx. So how to do something like this, how to integrate functions of this nature. Ms raised to power plus c raised to power n dx. So if you integrate this, you're going to have mx plus c raised to power n plus 1 all over the coefficient of s here. Which one is the coefficient of s? N. So all over that coefficient of s times this power, not this one, this new power, n plus 1, and you add plus c to it. That's what you're going to have. So let's say we have to integrate integral 6x plus 11 raised to power 3. What will be the answer is? That's how it's not far from 6x plus 11 raised to power 3 plus 1 over what is the coefficient of s here? Or we will differentiate inside. Differentiate 6x plus 11. What do you have? You are having 6 times this one, which is 3 plus 1. So that will give us 6x plus 11 raised to power 3 plus 1 is 4 over 4 times 6. What is that? 24. 24 plus c. Answer. That becomes the answer. So that's how you run through integral of these types. So let's say we have, let me solve more question. Integral. Let's say we have integral 6. Let me not use 6. Let me use 9 plus 6x raised to power let's say raised to power 4 dx. So what we have is 9 plus 6x raised to power. What will be the power now? I'll tell you the power. Power will be what? 5. This is 4 plus 1. That's 5 over this same 5 times what's the version of this s there? Is it 9 or 6? The version of s here is 9, 6. This is 6 plus c. That will give us 9 plus 6x. This power what? This one is supposed to be 5 plus 4 plus 1. We just add 1 to this. You're going to have 5. So you use this 5, bring 5 here back to this place. And then you mention this one. You pick the version of s here. Put it there. So all over what? All over 30 plus c. Remember this 5 here. This 5 and this power. So that becomes the answer. So that's how you run through all these integration of all these types. So what about we have integral 11 minus 10x raised to power 7 to dx. How are you going to go about this? Let's say we have done the solving as I'm writing the question. Integral 2 plus 3x raised to power 9. Raised to power 9. How are you going to go about this? Dx. Let's say we have integral 22x plus 9 raised to power 99. Yes. How are you going to go about this? So, you can see them. You can try them on your own now. Just remember this rule. Add on the power divided by the new power times the coefficient of let's say r plus c. Now, what is the power of it? Add on to that 7. Add on to 7. I'm going to have what? That's 11 minus 10x raised to power what? Add on to this 7. I'll have 8. Times that 8 times the coefficient of let's say. Now, which one is the coefficient of let's say? Which one is the coefficient of let's say? Is it 11 or 10 or minus 10? Which one is the coefficient of let's say? The coefficient of let's say minus 10 times this new power plus c. That's what we have. So if you multiply it, this minus will go to this place, minus will go to that side. Then this one times will give us 80. That's what we have. It will be minus. So this minus will affect this. Or if you differentiate this, you're going to have minus 10 as well. So if you do this, you're going to have 2 plus 3x. This power add on to this, you're going to have 10 over. Now, what is the version of s here? Is it 2 or 3? The version of s is what? It's 3. That 3 times 10 and it was 30 plus c. What about this? 22x plus 9 over. Add on to this one. That will be 100. 100 times the version of s here. Which one is the version of s? We're going to put the 100 there. Now, 100 times is it 9 or 22 now? The version of s is 22. Just pick the one that have s. Pick the one that have and stay with the s. Which is 22 times 100. I'll give you 2200 plus c. That is the answer. So please take note of that. It's very, very, very important. Now let's look at integration of these types. Integral of this type, integral k dx over ms plus c. All over ms plus c. So you take note to this c here and this c here, they are not the same. This c is a constant from the question. Why is another 6 is integration constant? So some textbook we put arrow here. You put arrow there. Which this arrow will become the integration constant. Which this one will be the constant for the question. Which is all those constants here. Check. It's constant. Check this question. We have constant. Check this one. We have a constant here. We have a constant. Constant is something that don't have x. And the constant there. Then the constant from that is in the answer. This is in the answer. It's after you have integrated the question, you just add it as integration constant. So let's look at something like this. If you do something like this, what are you going to have? So if you do this, you're going to have this, and the answer you're going to have k over the equation of s here. The same just as you're doing, you want to take this k divided by the equation of s. What is the equation of s here? The equation of s there is what? N. Then you take the log of the base. What is the base here? Ms plus c. This space will not be enough. The answer to this will be, let me write it this way. Write it this way. As you have this side, k dx over mx plus c. That's what I have now. K dx over ms plus c. Then this one give us k over the equation of s, you pick it, which is m. Then you take log e of the base, which is everything base, which is ms plus c, then plus the integration constant. Let me put r. Because this already has c plus integration constant. So let's say we have integral. Let's say we have integral 5 dx all over 6s plus 11. What will be the answer to this? So what you do? This one just, if you have a question like this, you're going to solve it this way. If you have a question like this, you're going to solve it this way. So after much practicing now, you understand. After you have watched this video over and over again, you get what we are doing. You just get the different questions we are having here. So if you have something like this now, following this rule, what's the k here? Our k is 5, measure of ds. Then what's m? M is what? Measure of s is 6, and the c there is what? 11. So I'm going to have 5 over 6 log e of 6s plus 11 plus integration constant is what? C plus c. That's integration constant. So now I have integral 2 dx all over 2 plus 11x. What will be the answer to this? The answer will be what? 2 over, what's the measure of s here? Is it 2 or 11? The equation of s here is what? It's 11 log e of 2 plus 11x plus integration constant, which is c. Now what about, I have something like this, integral 3 dx all over 7 minus 10x. 7 minus 10x, what do you say the answer is? The answer will be what? That becomes, 3 over what? 3 over what? Is it 3 over 10 or 3 over minus 10? This one should affect this 10, because 10 is measure of s there. So the one that is having s is 10, and there's 10 at the minus at the back, so that minus will show over 10. Then log of the full base, which is 7 minus 10s plus c. That's what I'm going to have. So I'm going to look at more questions under this. So look at how to integrate using partial fraction. Then we'll move on to the other stuff we have for the day. So, alright, let's have more questions under this. Let's we have integral dx over 9 plus 6x. What will be the answer to this? The answer will be what? For this place now, our case what? What's our key? Question of s is what? Question of dx is what? 1. Because what here? We have my 1 here. And our which one is the m here? Our m is what? 6. This is question of s there. Yes, having s here. So we're going to have k over this. Then log of the base plus c. Answer. So I'm going to have. So let's say we have integral 5 dx over 10 plus 5x. So what we done to this? We have 5 to scale over n. What's n here? 5 log e of what? 10 plus 5x plus c. 5 will cancel 5. We have log e of 10 plus 5x plus c. Answer. That's how we do it. So the next one I'm supposed to go into now is partial integration by partial fraction. So because of time, I won't be able to look at that integration by partial fraction. I will just show you how to do integration. It's just see this way. Now when you do integration by partial fraction, you have a question under partial fraction. Let me just explain it to you guys again. Remember, if I have a question under partial fraction, let's say I have, let's say 3 plus 6. Let me just say I have let's say 3x plus 2 all over 3 plus 3. Okay, let's say 3 plus x times, let's say s plus 3 times 6 s, let's say minus 2. That's what I just say, integrate it with respect to x. So what you do, how to do this? What you do, you first of all resolve this into partial fraction. That's what you do. Remember, in mathematics, how to resolve a fraction into partial fraction. I don't know if you can still remember that. How to resolve fraction into partial fraction. So very soon we'll do a topic under partial fraction. So for resolve this one into partial fraction, how do you do that? Just equate this function, which is s plus 3. Remember the denominator is currently factorized. Remember the things you consider when we do partial fraction. We ensure that the denominator is higher than the numerator, and after this, you first factorize the denominator, and after that, you equate these two. A constant over this first one, which is s plus 3, plus another constant, which is b, over this second one, which is what? S minus 2. So after you have resolved this into partial fraction using the normal way, want to resolve this partial fraction now, using this, just equate this to this one times this other, or you find the LCM of both sides. I'm teaching partial fraction here. Then after that, you have answer to this, you have answer to this. You come back, put it here, you apply this. Our k here now will be the answer you have here. Then if you say, if I'm going to integrate now, you now integrate this one with respect to x. So you go and look for a and b using partial fraction. Look for a and b using partial fraction, the principle of partial fraction. Using the principle of partial fraction. So you can also do that. Or should I just show you how to just do the partial fraction now? No, if you want to do the partial fraction, first thing, we ensure that the higher part, the power of s here, so that the power of s is the numerator. So we check s times s squared. We have s power 1 there. So s squared higher than s power 1. The next thing you do, you will factorize something is not factorized already. This is already factorized. The next thing, you find the LCM of this and this. Or if it is just 2 factors you have there, you have 2 factors there. You just use this to multiply this, and equate it to the numerator. So I'm not going to find this. Since I have just 2 factors now, I'll just equate this numerator to this one times this one times this. I'm going to have this times this. I'm having a s minus 2 plus b times this. I have b s plus 3. The next thing, you may either solve this using elimination way, which you first check how can I make a or b 0. Then next thing, you get the answer out, or you just solve it with your simultaneous equation. Solve A and B simultaneously. So there are 2 ways you do it. So if I want to do it simultaneously, you open the bracket. I want to do it simultaneously. I want to use elimination method, check. How can I make this bracket 0? So that if I multiply 0 times A, A will be 0 and B will still be empty. If S is 2, then we can eliminate that. So let's go and see what I do have. When S is 2, let's just have when S is 2. So if S is 2 now, I'm going to have 3 times 2 plus 2 is equals to A times 2 minus 2 plus B times 2 plus 3. Then I'm going to have 96 plus 98 is equals to 2 minus 2 is 0. Everything will be 0 because A times 0 is 0. Then this one I'm going to have 5 plus 2 plus 3 is 5, that's 5b. We have 5b there. So next thing, divide this by 5. So that b will now be equal to 8 over 5. So our b is 8 over 5. Our k there is 8 over 5. Our k is 8 over 5. Then what about the other one? The next one. What we're having as the next will be. Go back to this place again. Go back to this place. Go back to that place. Then go back to this place again. You now check how can I make B0 now? So that A, we can look for A. Now, what will I do right to be 0? Minus 3 plus 3, that is 0. So when s is minus 3, b will be 0. So anyway, cs 2 minus 3. Remember? So when s is 2, 2 minus 2, it will be 0. Then when s is minus 3 plus 3, b will be 0. So we have 3 times minus 3, then plus 2 equals to 8 times minus 3 minus 2 plus b times minus 3 plus 3. Then minus 2 plus 3 will be 0. Everything there will be 0. Then we're having this times this, that is minus 9 plus this. Minus 9 plus 2, that is minus 7. Is equals to minus, and this minus that is 5 minus 5a. We also have minus 5. This one give us, told you this is long, that's why I have to leave it. I'll give us this one equal to this one, and a will be equal to 7 over 5. This was 7 over 5. So what you do, you go back to this place, put A as 7 over 5, put B as 8 over 5, then you integrate to get your final answer. So that's how it's done. You have to put 7 over 5 there, put 8 over 5 there, then integrate the 2 for your final answer. If you decide to move that over 5, leave that 5 outside, then you just solve everything out, you get final answer. So ensure you do it. So the answer becomes, the answer to this one will be, since A is 7 over 5 over, conjugate of s is 1, then log of this, plus this one 8 over 5 over, conjugate of s is 1, then log of this one, plus c. That's all. Using that same method. So try and do that. So let's do trig functions. Go up to trig functions. Trig functions. Now for trig functions, remember we have sin s, cos s, and tan s basically. So if I integrate sin x, what will be the answer? If I integrate cos x, what will be the answer? If I integrate tan x, what will be the answer? That is the first thing I'm going to look at now. Integrate cos x, sin s, tan s. Now for sin s, I'm going to have minus cos x plus c. For cos x, I'm going to have sin x plus c. For tan s, I'm going to have something very lovely. We're going to have something very lovely. Remember, I'm going to have log e of sec x plus c. That's how I'm going to have it. Base e. To base e of sec s plus c. Then we integrate cos x. Integrate cos s. That's how it be. I'm going to have log e. Remember, cos is of sin s plus c. Sin s plus c. I'm going to show you how to got this. I'm going to show you how to got this later. Then if I integrate sec square x, integrate sec square s ds. That's how we tan s plus c. So I'm going to show you how to got this and this later. Because that is not straightforward. Those two are not straightforward. So let's say I want to do integral sin 7x dx. What will the answer is? Remember, if I integrate sin s, I'm going to have minus cos s. So if you do this, I'm going to have minus cos 7x over, differentiate this 7. That's why we're doing that exponential function that have e as the denominator. So if you use now, differentiate this 7x, you're going to have 7. You see, that becomes the answer. That becomes what? The answer. So we are still going. Then, let's say if I want to integrate cos 8x dx. That's how it becomes. Remember, if I integrate cos s, I'm going to have sin x. So if I integrate cos 8x, I'm going to have sin 8x over differentiate 8x. I'm going to have 8. You see. That's what I'm going to have. So let's say we have integral sec squared 3s plus 4. If I do this, I'm going to have, remember, if I integrate sec square s, I'm going to have tan x. I'm going to have tan 3s plus 4. Now, differentiate 3s plus 4, but differentiate down to get the final answer. Differentiate 3s, I'm going to have 3 plus c. That's what you are going to have. These are the rules under trig function. So let's do more under this trig function before we go to integration of special types. Integration of special types of integration. Special types of what? of integration. Special type of integration. Special type of integration. Special type of integration. Then we look at reduction formula. We have a way of solving that. Look at integration by parts. Look at integration by parts. We have a lot of things to do in this place today, so please just go with us. So we are doing trig functions now. Trig functions. Let's say we have integral cos 11 minus 5x dx. So if you do this, what are you going to have? There's no wasting of time. If I integrate cos, I'm going to have sine, not minus sine. So when you differentiate cos, you have minus sine. If you integrate cos, it will be sine, not minus. If you differentiate sine, you have cos. If you integrate sine, you have minus cos. Think of that too. So 11 minus 5x, then over differentiate that 11 minus 5, what are you going to have? Differentiate 11 minus 5x, I'm going to have minus 5 plus c. Oh, just the way you're going to press here, minus 5. Remember that, r plus c. So I have integral sine 2s plus 1 dx. What will be that to this? That will be minus cos 2s plus 1 over, this, you have 2 plus c. Take note of that. Now let's look at hyperbolic functions. How to integrate hyperbolic functions. That integration hyperbolic. Remember functions are what? Sin x, cos x, and so on. So if I integrate sin x, what am I going to have? Integrate sin x, what am I going to have? I'm going to have cos x, there's no minus, plus c. If I integrate cos x, I'm going to have sin x plus c. There's no minus for this. But still follow the same rule with this trig function. As you say integrate now. The same thing for, but one thing about this is that this one don't have minus. That's what you should know. This one don't have minus. As you say integrate sec square s, if you use an f, right? As you integrate sec square s, the answer will still be sin s plus 2. Let's go around. So let's say we are integrating integral cos, you don't have this now. 11x plus 3 dx. What will be the answer? And with cos x, I'm going to have sin x. So what we have is 11x plus 3. We don't differentiate, just as we are doing for trig, the same thing. Differentiate 11x plus 3, I'm going to have 11 plus c. Let's say integrate cos 5x. Give cos 5x, I'm going to have sin 5x over differentiate 5x, I'm going to have 5 plus c. So that is very, very important. The whole idea, if I say integrate sin 11 minus 6x, what will be the answer? Ds. That becomes cos 11 minus 6x over, this is the way of integrating this, over differentiate 11 minus 6x, so you have 11 0, differentiate minus 6x, I'm going to have minus 6 plus c. That's what you are going to have. So this is how you do for trig functions. Now let's look at special form of integration now. Special forms of integration. Because there are much. Look at special forms of integration now. Then we go to integration by parts. Now, type 1. Integral of types. You have this type. This is type 1. Integral f prime of s all over f of x dx. What will be the answer to this? If you have integration of this type, the answer becomes log e. Okay, let me put the answer in log e of f of x plus c. That's what I'm going to have as the answer. You have log e of f of x plus c. Now, what's the meaning of this? This means something like this: 1 over x dx. Now, what do I say? It means that if you have a question in integration, listen to this. If you have a question in integration, it says that when you differentiate the denominator, the answer becomes the numerator. Automatically, if you integrate that full function, you integrate everything that is here. This says that if I differentiate it, the answer will be this. If you integrate everything now, the answer becomes log of this denominator here plus c. That becomes the answer. For example, now, if I differentiate x, the answer becomes 1. So if I integrate everything here now, since we have this answer here, it says that we have this condition satisfied. It says that if I differentiate this denominator, then I become the numerator. the final answer becomes log E of this denominator here plus C. That's what we're going to have. So let's say we have something like this: integral x plus 1 all over, let us go 2x plus 1 all over x squared plus x plus 8 dx. Let's have something like this. Let's have something like this. Now, if you compare this to this, our f of s is what? What's our f of s? The denominator. That is s squared plus x plus 8. Now, what about the f prime of x? You don't go and look for the f prime of x here. Just say the f prime of x is this. No. The only thing you do, just check, just bring out this f of s, which is always the denominator of the function of this type. Then to get the f prime of s now, you will differentiate this denominator you got. Differentiate s squared, we have 2s, plus differentiate this, you have 1, plus differentiate is 0, that will be 2s plus 1. 2s plus 1. Then you now check, this f prime of s that is here, is it the same thing as this one? Let's check. The f prime of s we get was 2s plus 1. Let's check. 2s plus 1 is the same thing. So since when we differentiate, the answer will be this, they said if you differentiate this one, the answer is this. Then the answer final answer will be log of this denominator plus C. That is the rule. So see, if I differentiate this one, the answer is this. Automatically, the final answer of this question will be log E of this denominator. The final answer will be log E of this denominator, which is s squared plus s plus 8 plus it does become the answer. Why? Because if I differentiate the answer will be this. So automatically, the final answer will be log of this to base E plus C. So let me do another one so that you see what I'm trying to say. Integral. This is having 2 bracket x plus 1 all over s squared plus 2s minus 12 dx. So how are we going to run through this? So look at what I'm going to do. The first thing, bring out your f of x. Bring out the f of x is what? S squared plus 2x plus minus 12. And what is the f prime of x? It means differentiate this value of f prime of x. So differentiate this one, now we have 2x plus 2 minus 0. Abi? Differentiate now that will be 0. Differentiate minus 12. So factor out 2, we're going to have 2 brackets, x plus, factor out 2 from here, only one will be there. So this and this, are they the same? Check. This and this, are they the same thing? They are the same. So if I differentiate this and that, the answer will be this. Automatically, the final answer will be log. Final answer to the question will now be log E of this denominator, s squared minus 12 plus C. That's it. What about if it's not like this? Integral x plus 2. Okay, let me say s plus 2 all over s squared plus 4x minus 3 ds. What about if it's not like this? What is the f of s? The f of s is what? S squared plus 4x minus 3. Then what is about the f prime of x? F prime of x is 2x plus 4. 2s plus 4. Actually, this one I'm going to have 2s. Actually, I'm going to have 4. Actually, I have 0. So check. This and this, are they the same thing? No, they're not the same. So what do we now do in this case? You check. Is there a relationship between this and this? Yes, there's a relationship. The relationship is that if I multiply this one with 2, I'm going to have this. That means this one is higher than this by a multiple of 2. That's 2 times this, will give us this. So what am I going to do? What you just look at what we are going to do. Since to get this one now, to get this in this place, I must multiply this one by 2 to get this. What you just do is either you write the final answer out and divide the final answer by 2. This one is higher than this by 2. Or you just do this way. Now something like this, you say integral. Since what we have in this dimension of this is 2 times this. So say 2 times s plus 2. Since that's what I'm having here, I'm saying 2 times s plus 2. Then s squared plus 4s minus 3 gs. Then if I differentiate this one, that's will be this. But this question and this one are no longer the same. For this question now to go back to this, you must cancel out this 2 in a way. How will you cancel that 2? Multiply everything by 1 over 2. You multiply everything by 1 over 2. You use this 1 over 2 to multiply this to 2, will cancel out 2. Then the 2 will still be the same thing. But I'm not going to multiply 2 because what I need is this. So I will just bring this one out as a constant. Then if I differentiate this one, the answer will be this. So the final answer will be you take the log of this denominator, which is s squared plus 4s minus 3 plus this. That's all. Remember, look at it. It's a very simple thing. If I measure this, I got this. Check. Can I manipulate this to be this? Yes. It's either I will factor out 2 away, or just remove 2 from it. So the 2 will not be here. Then I think, or it's not even to factor out 3 away. What you just do, can I manipulate this one to be this? Yes. I can multiply this one by 2 to be this now. So what you do, you don't multiply this one with 2, and multiply the denominator with 2 as well, so that the 2 will not change the question. Then you move the denominator outside, so that the 2 will not be active. You multiply this one with 2, now we have 2s plus 4. So if I differentiate this one now, I have 2s plus 4, which is the same thing as this. That's going to be log of this plus c. But remember, there's half here. I will balance out this denominator. That's what I did. So this one, I cancel out this 2, so that the question will still be s plus 2 over s squared plus 4s minus 3. So I will not cancel it out. I will not keep this one here. So if I make it on the side of this, that's going to be log of this plus c. That's right. That's just the little manipulation there. So let's do this. Let's have integral of 5 plus 10x over 5 plus 5s plus 2s. Okay, 5s is equal to 5s squared. So let's do this to see what we're going to have. Let's check. If I differentiate this in another this, already 5, 0. Differentiate 5s, 5. Differentiate 5s squared, 10s. See? This one is very simple. And differentiate this one, and the answer will be this. Automatically, the answer will be log of 5 plus 5x plus 5s squared to be c. That will become the answer plus c. That will become the why? If I differentiate this, the answer will be this. Let's do another one. Let's do this. Integral cot s ds. Integral cot x ds. Let's do this one. I told you I'm going to show you how to do this. Then you go and do for sine s. I'll do for sine x. Then, look at this. This one I'm going to change it to cos x over sine x ds. Because cos s is the same thing as cos s over sine s. You see? Then you now check from this rule. If I differentiate sine s, will the answer be cos s? Check. If I differentiate sine s, what becomes the answer? The answer if you differentiate sine s, the answer is cos s. If you differentiate cos s, the answer will be minus sine s. Don't misquote integration for differentiation. When you integrate sine s, if you integrate sine s, the answer will be minus cos s. If you differentiate sine s, the answer will be cos s. When you integrate cos s, the answer will be sine s. When you differentiate cos s, the answer will be minus sine s. Take note of those two. It's just opposites of each other. Remember, integration is opposite of differentiation, anti-differentiation. So, since if I differentiate this one now, f of x is sine x. F prime of x is differentiate sine x, you have cos s. Since when I differentiate this, the answer is this. Automatically, that answer will be log e of denominator is sine x is sine x plus c. That's what I'm going to have as your final answer. So you go and do this one integral sine x dx, which is same thing as integral sine s over cos x. Yeah, because sine over cos is sine. If I differentiate cos s, it's going to be minus sine s, not sine s. So we are going to do some little manipulation here to ensure that we have minus here. Can we move the minus outside? Or what you do, there's no need to move the minus outside so that the thing will not still work. So what you do here, try and manipulate it. It says that after this, the answer has to be plus, there will not be minus there. What you're doing, I can multiply this one by minus 1, so multiply this other one by minus 1. Maybe 1 over minus 1 times this minus this. The answer will be 1 over minus 1 times the final answer. Then you now manipulate it, you get this answer out. The answer will now be log e of sec x plus c. That's what we have. Log e of sec x plus c, that will become the final answer. So do your work and see if you can get this answer. So now let's look at the other aspect. Another aspect of this, it says that what we are not doing now, we want to check if you have something like this, integral of this type. Let's say type 2. Type 2, let's say we have integral f of x, that is f prime of x all over the square root of f of x ds, something like this. Let's say we have something like that, what becomes the final answer. That's what we look at now. It's still very, very simple. Very, very, very simple. It still follows this. Still follows this procedure. Just that the answer, both of the answers are not the same thing, but both procedures are the same. Both procedures are the same. Both answers are not the same. So the answer for this now, if the denominator is having square root, the answer will becomes what? And the answer will be 2 times the denominator plus c. That becomes the answer. I hope you can explain this. If you have a question, for example, let's say we have 1 over root x dx. If I differentiate x, I'm going to have 1. That's what I mean. What I'm going to differentiate the denominator is what inside the root of the denominator, then becomes the numerator. The final answer becomes 2 times the denominator plus c. This one can become 2 times. What is the denominator? Root x plus c. That becomes the answer. So let's say we have number 1. Let's say we have integral x plus 2 all over. Let's say we have 2x plus 1. Let's 2x plus 1 all over x squared plus x plus 3 dx. And this one is now having square root. Remember, if you don't have square root, you take log e of the base. If it's not having square root now, check. What is the f of x here? F of x is x squared plus x plus 3. What is the f prime of x here? F prime of x is what? We show this. We have 2x plus what? 2x plus what? Plus 1. We show this one, we have 2x, we show this one, we have 1, we have 0. So if I check this one, they are the same thing. So if I measure this inside this place, I'm going to have the numerator. So the answer becomes what? 2 times the denominator, not log e of the denominator of this side. That means since it's having square root, anyone has square root, the same thing with the first one we did. So the answer will now be 2 times the denominator. It's 2 times x squared plus x plus 3 plus c. That becomes the final answer. So let's say we're having this question 2. Let's say we're having this question 2. We have integral 3x plus 2 over 3x squared plus 4x minus 8, then square root dx. How will we do this? Like this. If I measure 3x squared plus 4x plus 8, the answer will be this. Let's check. Measure 3x squared, we will have 6x, not this. Look at it. F of x is 3x squared plus 4x minus 8. Now what will be f prime of x? Differentiate this, we're going to have 6x. Differentiate this, I'm going to have 4. Differentiate that one 0. Check. This and this. Did it say? What does it do? How will you do? Let me just give you a short way. Like the first one, remember the first one? We'll now multiply this one by. Let's check. What is the difference between this and this? If I multiply this one by 2, I'm going to have this. Check. 2 times 3, 6. 2 times 2, 4. So multiply this one by 2, I'm going to have it. Remember we had that before. Then we'll now multiply this one with 2. Then we want to go multiply this one again with half. So that half times 2 will cancel out. Can you remember that? So at the end of the day, we now say the answer will be half times. Then you now write answer. What is the answer? If I reduce this answer, the answer will be this, which is 2 times this 6, 2 times this one 4. Then at the end of the day, we now say okay, the answer will be 2 roots of this denominator, which is 3s squared plus 4x minus 8, then plus c. So this thing will cancel 2. We have 3s squared plus 4s minus 8 plus c. That's what I'm going to have as a final answer. Remember we did that before. Now let me give you a very short way to do this. Let me write down that one out. Integral 1, okay, s plus 1 all over s squared plus 2x minus 1 square root. Now, if you differentiate this, f prime of that s will be, differentiating this, we're going to have 2x plus 2 minus, okay, 0. That's what. So you check, what is the difference between this and this? The difference is, if I multiply this one by 2, I'm going to have this. 2 times s, 2s. 2 times 1, 2. So what do you now do to get your final answer? If you check this answer you're getting from the derivation of this, the denominator here, the derivative of the denominator is higher than the numerator by a particular digit or value. What you do, write out the final answer and divide that answer by that digit. If this answer here is higher than this one by a particular value, write out the answer. What is the answer? The answer is supposed to be 2 times the denominator for square root to s squared plus 2s minus 1. That's supposed to be the answer. Plus c. That's supposed to be the answer. But since this one is higher than this one by a particular digit, we write out the final answer and divide this answer by that digit. So what I'm going to divide this answer by the digit, in which I will multiply the answer by 1 over the digit, means divide the answer by the digit. So that you say divided by 2, or you just say times 1 over 2. You see the same thing. Since it is the digit now, so I say that this by 2, that is digit. Multiply this one by 2, I'm going to have this. So that this will cancel this, and we'll have root of s squared plus 2s minus 1 plus c. I don't know if you understand that. If you discover that the answer you are having here, when you differentiate this denominator is higher than this by a particular digit, both for the one I did before and this one, what you do, you write out the final answer and divide that answer by that digit. But if this one is lesser than this by a particular digit, what you do, you write out the final answer and multiply that answer by that digit. If this one is less than this by a digit, you multiply the answer by that digit. If it is higher than this by a digit, you divide the answer by that digit. Take note of that one. It's very, very important. Let me check and see if you guys can do this too now. Integral of exponential x over the square root of exponential x dx integral x plus 2 over the square root of s squared plus 4s plus 9 dx. So what will be the answer to this? What will be the answer to this? So do that. Everything you can do it. What will be the answer to this other one? Let me remove square root from this one. So that if you understand it too. What will be the answer to this second one? What will be the answer to this? What will be the answer to this? Try and see if we can do those two. Then I will put the answer now. Try and see if we can do it. The answer to this will be 2 times f of x plus y. If I differentiate exponential x, let's also be exponential x. So if I differentiate this one, I'm going to have this. But that will be 2 times this and become the answer. What about this? What about this other one? What is the answer to this? The answer will be, if I differentiate this, I'm going to have this. But the answer I'm going to have will be 2 times this, which is 2 higher than this. Since this answer here is 2 higher than this, you don't have 2s, you don't have 4, you don't have 0. So 2s plus 4 is higher than this one by 2, a digit of 2, which is 2 times s give us 2s, 2 times will give us 4. So since this answer is higher than this by 2, you have write out the answer. What is the answer? Remember, this one don't have square root. Anyone that don't have square root, the answer will be log e of that denominator. That denominator plus c. That becomes the answer. If there is no square root 2, but if there is square root, the answer will be 2 times the denominator plus c. 2 times root of the denominator plus c. Take note of that too. If there is no denominator, then you're going to have this. But since this one is 2 higher than this, I will divide this answer by 2. In the sense that I'm going to multiply it by 1 over 2. I'm dividing by 2. If I want to divide by 3, multiply by 1 over 3. If I want to divide by 6, multiply by 1 over 6. That is all. What about if the question was like this? X plus 2 dx over the square root of s squared plus 4s plus 9. The thing is the same thing. But this one is not having square root now. The final answer will be 1 over 2, like I still hear me there. Then we will not take log again, no. We take 2 times the denominator. That's how you get the final answer from anyone that have like log plus c. Just use 2 to multiply the denominator. That's the one you have for square roots. So that this one will now cancel this. You have root of s squared plus 4s plus 9 plus c. That becomes the answer. There's another split one. I'll just quickly like to introduce. You have integral f of s times f prime of s ds. That's how it becomes f of s squared over 2 plus c. That's what I'm talking about. If you have two functions, then if I differentiate this, the answer will be this. Automatically, the final answer will be when you square this first one and divide it by 2. For example, something like this, you have something like this. Integral log x to be e over x dx. That's something like this. Remember this one is same thing as integral log x to base e times 1 over x, because this one x is the denominator, you can something like separate the two, dx. If I differentiate log x to base e, what will be the answer? 1 over x. Abi? If I differentiate log x to base e, the answer becomes what? 1 over x. So this differentiate, the answer is this. The final answer will be this 1 squared over 2. So since my differentiation, the answer will be this. The answer will be log e of s, then square it over 2 plus c. That becomes the final answer. So anytime you have a question and it's form of a product, it says that if you differentiate the first one, it's not the second one. The final answer will be when you square the second one plus c. Remember, let's say for example now, let's say you have something like this. Before I just call it today for this and go to the other part. Let's say you have integral tan x times sec square x dx. So let's say something like this. If I differentiate tan x, what becomes the answer? Sec squared. So the final answer will become tan square x all over 2 plus c. Or tan x everything squared all over 2 plus c. That becomes the final answer. Physics of this rule is still very important. See, if I mention the answer is either be this 1 squared over 2 plus c. So now let's look at special integration from inverse trig and inverse hyperbolic functions. Special integration from inverse trig and inverse hyperbolic function. We are still going somewhere. So stay with us. Alright, let's look at integration of inverse trig and inverse hyperbolic. Case 1. Case number 1 is we have integral dx all over r squared plus s squared. What will become the answer to this? And integral k dx all over a plus b s squared. These two things we are going to look at now to check for the answer. So please follow us with this because we are going to be using my return rates for this case. All these cases, we have case 1, case 2, case 3, case 4, case 5, and so on. Look at. So please follow us as we follow mathematics. So remember when we are doing the differentiation, we are going back to differentiation now. Now remember when we differentiated tan inverse of s, cos inverse of s, cos inverse of s, tan inverse of s, and so on. The answer we are having. If you integrate those answers back, you get the equivalent inverse trig and inverse hyperbolics. So this one having, if you integrate something like this one is from tan inverse. So if you integrate one, I'm going to have 1 over arrow tan inverse of x over arrow plus c. That's what I'm going to have. 1 over arrow. If this one gives us k over root ab tan inverse of root b over a s plus c. That's what I'm going to have for that. So take note of this. It's very, very important. Take note of this. So you use this. Now this will only work if this s don't have a coefficient and this other side don't have a coefficient. But this one will work for any question of this type. This will always work. But this one will only work if s don't have coefficient and there's no coefficient here as well. For example now, this is question 1. ds over 3 plus s squared. Something like this. So if I say solve this question, what do you compare this to this? Remember, if for 3 plus s, there's no square. We use that case we did before. We said that will be k over m log e of the denominator plus c. But if it's not having square, if it's having square, it means there is something there that we have to bring out. There's something there that we have to bring out. So this one is higher than this. Very well. So we have a square here. We have a square. It must be squared and it's s squared. So if you compare this to this, that's what you do here. We just do comparison. Our s squared is s squared settled. R squared now will be 3. Just compare. Just do comparison. This plus must be plus. S squared must be s squared. ds. R squared now is 3. So that what you do, you take the square root on both sides. This one cancel this. Our arrow will now be root 3. So they say if you have this, the answer will be this. In this question now, our arrow is root 3. So okay, finally, the final answer will be 1 over 6 arrows root 3. Put root 3 there. Tan inverse of x over root 3 plus c. Then to solve this one, to change it to root 3 over 3, also have root 3 over 3 by rationalization. So it will be 3 s root 3 over 3. Because s root 3 over 3, you can just leave it as 3 over root 3. You don't have to be root 3, you don't write s root 3 over 3. That will rationalize the solve. Then plus c. That becomes the answer. So this either becomes the final answer, or this other, whether this or this are correct. So now, let's look at this other one, integral ds over 4 plus s squared. Whether it's s squared plus 4 or 4 plus s squared, both of them are the same thing. So, if we do this now, compare this to this. Our s squared is s squared. Plus is plus. Then, our r squared here will be equal to what? 4. So, the r will be root 4, which is what? 2. So, the final answer will be this, which is 1 over r. And what is r in this question? R is 2 here. Then, tan inverse of what? X over r. X over, what is r? 2. That's how we run these steps. Okay, let me just solve integral. Let's say dx over 16 plus s squared. 16 plus s squared. Just compare this to this. S squared is s squared. Plus is plus. R squared now, for this question will be what? 16. So that our r will now be equal to 16 is equal to what? 4. That's the discount on both sides. Then the final answer will be 1 over r. 1 over, what's r here? 4. Tan inverse of s over r. S over, what's r here? 4 plus c. Answer. That's how we do. And let me look at the question in this other side. Let's say we have integral 4 ds all over 4 plus let's say 9s squared. So like this. Check, we have a number here now. No number here for this. So this one now, this method will not work. Only this case will work. Because k is equals to, that is, just compare the k here, product of ds. So this k is 4. Then a here, so this a here, a is also same thing as 4. Then b is equal to 9. Just compare this to this. The next thing, the answer will be k over root ab. K over root ab. What's a? A is 4, b is 9. Tan inverse of root b over a. Root b over a is root b is 9, o is 4. X plus c. So that at the end of the day we'll be having 4 over, what root 4 is what? 2. Root 9, because the square is covering everything. Root 4 is 2, root 9 is 3. But just take root 4 times 9, we give the final answer only 6. Then that's tan inverse of root 9 is 3, root 4 is 2, s plus c. And we call the final answer. So 2 times 3 give us what? That will give us 6. That will be 4 over 6. 4 over 6 will give us 2 into 4, 2. 2 into 6, 3. So let me look at another one so that your mind will be there. Integral 5 ds all over, let's see, 9 plus 15s squared. Look at this to see. In this question now, our k is what? That is k. K is, what is k this question now? We're going to 2 over root ab. What is k? K is 5 over root ab. And a, b, or a is 9, b 16. The tan inverse of root b over a. Root b over a. B is quadrant of s b. A, s plus c. So that we'll have it 5 over. What is this over this? It's 3 times 4. What is that? 12. This one is 3. This one is 4. 3 times that is 12. Then tan inverse of 12, okay? Root 16 is 4. That is 4. Root 9 is 3. Over 3 s plus c. That is the answer. So try and do this one now. Integral dx over 6 plus s squared. Integral ds over 9 plus okay, let us say 6 Let's say 4 plus 9s squared. Now this one, let's say we can do it. Let's say we can do that. So this, that's how it becomes 1 over root 6 tan inverse of x over root 6. So I think you can decide to rationalize that one, no problem. So I did it. That's what it is first time. We're going to do it this way. Then this other one fall into the second one. It says that this is having a coefficient. We know this one is having a coefficient is 1. So our k here is 1. So our k here is 1. A is what? A is 4. B is what? 9. Remember, A is the one that I have here. B is the value of s squared. K is the one that's having in the numerator with k. So we have 1 here, imaginary. So our k is 1. Our A is this one that I have s. Then B is the value of s. I'm going to have k over root AB is root 4 times this. 4 times 9. Tan inverse of root B over E s plus c. That will give us 1 over 2 times 3, that's 6. Tan inverse of root, okay, that's root 9 is 3, root 4 is what? 2. S plus c. That becomes the answer. So this is how we are going to be doing in this inverse question. Now let's look at the next one. Let's assume, let's say we now have this one now, square root, and this one will be negative. This one negative, and we have square root. That's what I want to look at now. This one, let's look at this slide. Let's look at this slide. Let's say we have this. First one is now r squared minus s squared, but it's having square root. Remember the first one was r plus s squared, there's no square root. Let's try that one to see what we are going to have. Let's see what we are going to have. So, please just try and follow up. This is integration for you. Integration for you. So, let's see here what we come down to this. Let me write this out to be very clear. It's now square root of a minus bs squared. So it's r squared minus s squared. It's still the same thing. Still the same thing. I'll be very fast with this now, since you are already gotten the check. So this one was the answer for this is ref of tan. Tan is when you have r squared plus s squared, the square root. And now this is going to sine inverse of s over r plus c. So I'll give us k over root b, sine inverse of root b over a s plus c. So we have s plus c. There's s here. S plus c. So let's say we have a question here, integral dx over square root of 3 minus s squared. Like this. So compare this to this. Remember, if an is falling into this, not this. So that our arrow square is equals to, compare this to this. Minus is minus, s square is s squared. Arrow square is not 3. And arrow will be square root of 3. And the final answer will be sine inverse. Final answer will be sine inverse of s over r, which is 3 plus c. Let's see, we have another question here. Another question. Integral dx over root, let's say 25 minus s squared. 25 minus s squared, what do you have? R squared here is 25. Then r will become root 25, which is equal to what? 5. So you just come, the answer becomes sine inverse of s over r. Sine inverse of x over r plus c. That is all. Remember what I said before. We're just trying to do shortcuts here. Then let's look at another one. Look at this one. Let's say integral 5 dx all over 4 minus 9s squared. 4 minus 9s squared. So this one now fall into this other one. It says that you now say k is equals to, when our k is equals to what? 5. A is equals to what? A is equals to 4. B is equals to what? B is equals to, is it minus 9 or 9? Check. Minus is equals to minus, B is equals to 9. So the minus have to be taken care of. Minus, they take care of. B is now what? 9. So that we now be having something like this. And we have something like this. K over root B. K is 5 over root 9. Then sine inverse of root B over A.
root b, which is 9 over 4 s plus c. That gives us 5 over 3 sine inverse of root times 3 over 2 s plus c. So you try this one. Integral. Let's say we have 2 dx over the square root of 3 minus 2, let's say 3 minus 4s squared. Try something so you can do it. And then the answer, the final answer will be k over root b is 2 over 2. That's already out. Then sine inverse of root b over a, which is 2 over root 3, or 2 root 3 over 3. That is correct. 2 root 3 over 3 is still correct. Yes. So try and see if we can do this. It's very, very, very important. Extremely important. Very, very, very important. So let's look at integral of this type. This one is case 2. Now let's look at case 3 now. Case 3. Curve time. Let's look at case 3. Now let's say we have integral. See something like this now. Then we now interchange it. We now interchange this one now. Let's say we have integral dx over arrows. Okay. We're having arrow square minus s square. Let's say we're now having integral s square minus arrow square now. It's now s square minus arrow square. We are interchanging it. What will become the answer? Let's say we have integral k ds now. We have k ds over the square root of b s square minus a. Just like this other one now. What we are doing now, we are interchanging the denominator. Instead of arrow square minus s square, now doing s square minus arrow square. If we interchange this one, what will be the answer? Will the answer still be the same? No. The answer becomes cos inverse of s over r plus c. That will become the answer. Then this one becomes sometimes we will put plus or minus here. Then we will put plus or minus there. Then this one becomes k over root b, k over root b cos inverse of root b over a x plus c. That will come the answer of this other one. You see? This one is sine. The only difference between this and this is that this one is cos, but this one is sine. Other procedures are the same thing. They are the same. For example, like I say, solve integral dx over the square root of s squared minus 3. So we are doing 3 minus s squared. The answer will still be equal to cos inverse of root. That is s over root 3. Yes, that will become the answer. You don't have sine inverse of s over root 3 plus c. Well, you know, just take cos instead of what? Sine. That is related there. So, let's say we have integral ds over square root of s squared minus 4. Integral dx over square root of s squared minus 5. What will be their respective answers? What will be their respective answers now? Let me check if you are following. Just it's the same procedure. What we are doing. Remember, we will compare. Our ds is ds, s squared is s squared. 3 now is what? Arrow square. Arrow now be root 3. Just take the square root. To get out of here, to get out, what you do? Take the square root of what you have in there. So take the square root of 4. Now what is that? 2. Take the square root of 5. 5. So it will be cos inverse of s over 2 plus c. Cos inverse of s over root 5 plus c. That's what I'm going to have. Just to get out of here, take the square root of what they have here. Let's to get out. Then, what about we are having the square root of 2 dx all over square root of 5s squared minus 3. 2 dx over square root of 5s squared minus 3. The answer will become our k here. K is what? This and this are. We are comparing this to this. Our k is what? 2. Our a is what? 3. And our b is what? Our b is equation of s, which is what? 5. So we come back to this answer. K over, what is k? K is 2 over root b. B is what? 5. Then cos inverse of what? Cos inverse of root b over a. Root b over a x plus c. That's why I will have answer. answer. So if I say I have something like this now, integral 4 dx all over square root of 4s squared plus 4 minus 4, not plus. But it's minus for this. So what will be the answer to that? What will be the answer to that? That's how become k, which is 4 over root b. Which one is b here? 4. This b, this one is b. Then cos inverse of root b over a s plus c. So that's going to give us 4 over 4, which is 4, 4 is 2. 4 over 2, that's 2. Cos inverse of 4 over 4, 1. Root 1 is what? 1. X plus c. Answer. So try this. Integral 2 dx all over the square root of 9s squared minus 4. Try and see if we can do this. Final answer is going to be, write the final answer is going to be 2 over 3 cos inverse of, join your hand to solve it, will be over a. Will be over a, guys. 3 over 2 s plus c. That's what we have as your final answer. Now, let's look at other cases. Now, let's look at this case now. This and that. Remember, we look at the case with those square roots, we have a plus. Now, let's say we are having square root now, and it's now plus for both of them. This one is now plus, it's now plus. This one we did before. It's not minus today, it's now plus. If it's plus, so both of them, if this one is plus now, this one is plus, this and this will be the same. Because arrow square plus s square. S square plus arrow square will now be the same thing. And there's no changes. Look at it. 3 plus 2, 5. 2 plus 3, 5. There's no change. Whether it's a 10 plus 2, there's nothing. It's going to happen. But plus is commutative. Now let's do it more now. If now plus, this stuff is now plus. What are we going to have? That's the next thing. It's now plus. What are we going to have? Now, I hope you are following. As the first guy is the number 1 thing there. I hope you are following. Although the thing is not that very easy, you have to be encouraged. And follow it. Just try and get what we're trying to do in this place. We're just doing comparison here now. We're not actually solving mathematics. We're just doing the comparison, saying that we're trying to use shortcuts. We don't want to be solving long solvings here. So let's say we have cos. Let's say case 4 now. Case 4. Now case 4. Let's say we now have integral ds over square root of, let's say, s squared plus r squared, or integral k ds all over the square root of as squared, that's bs squared plus a. So we have this. This is what we have. The answer will still be the same. But this one becomes sine instead of sine. S over r plus c. So I'll be k over b sine or its inverse of root b over a s plus c. Its inverse is sine inverse, not just ordinary sine. You know what I'm doing? We have done sine inverse, tan inverse, cos inverse, so it's now sine inverse. If it's plus, let's say we have integral dx over the square root of 3 plus, or s squared plus 3. S squared plus 3 or 3 plus s squared. S squared plus 3. Not that we have. Remember how we did this one before, maybe? Compare this to this. Ds is ds, s squared is s squared, r squared is 3. So if r squared is 3, what's now? Take the square root of this. We have sine inverse of s over what? 3. Let's see. Let's say we have integral dx over the square root of s squared plus 6. Integral ds all over the square root of s squared plus 4. What we have to come down to this. From what? Sine inverse of s over root 6 plus 6. Sine inverse of what? S over what? Take the square root of, that's the square root of this one is what? 2. This is not the that's how I'm doing it like that. It's very simple now. It's very simple. Now let's say we have integral. This is 5 dx all over the square root of 4s squared plus 9. This one our a is what? 5. Everything is still the same. Our a is what? 9. B is what? 4. Everything is just the same thing. That's why I will not do this one much. I will just do it later. Then I will just go to the next thing I have in my agenda. So look at it. If there's no square, remember if there's no square root, we will return, we'll take note of that. So if I want to do that now, it will be k over root b. This is k, that is k over root b. K is what? 5 over. This one is this one is b, this one is a. Sure, just compare this to that. The next thing I'm doing this, that's how I'm just rushing it. K over root of what? What is root b? Root b is what? Root 4. The sine inverse of root b over a, 4 over 9. S plus c, that gives us 5 over 2. Sine inverse of 2 over 3. S plus answer. Remember, what we started from? Integral dx over x r square plus s square. So the answer will be what? The answer will be what? 1 over r tan inverse of s over r plus c. I don't consider remember that. So we started from. Now, let's assume this one is not like this. Dx over s square minus r square. There's no square root. Remember, if there's square root, it will be sine. If there's no square, what will be the answer? The answer is that going to come from when you take the remember this one is difference of two squares. It will be r minus s times r plus s. You now use what's it called, the partial fraction to expand it before you integrate. Or the answer will just come from this one. If you differentiate tan inverse, it becomes 1 over r tan, not tan, tan inverse of s over r plus c. Or this one becomes tan. If it's like this, let's use like this, dx over, this one is not coming before this, s squared minus r squared. There's no square root as well. This one becomes 1 over r cot inverse of s over r plus c. So I do math. So please take note of all these little things. If it's plus, it's tan inverse. If it's r squared minus s squared, there's no square root. It's tan inverse. But if it's s squared minus r squared, there's no square root. It's cot inverse. But if there's square root here, it will be cot inverse. If there's square root here, it will be sine inverse. If there's square root, it will be sine inverse. If there's square root for this, it will be sine inverse. Take note of the 6 things we have done here now. Now I want to look at something, another thing very important. It says that this denominator is now presented in form of quadratic equation. How do you solve it? This one is a little bit long, or maybe I'll just leave this, then move to integration by parts. So integration by parts is the next one in the agenda we have to look at now before we call it a day. So right now, integration by parts. Let's look at integration by part now. Now, integration by part helps us to integrate two dissimilar functions that are in terms of product, in form of product functions. Remember, we did product rule from this derivation for integration by part. We actually went from that product rule we did. Now, it's not that if you have integral u dv, we say we are going to take it as uv minus integral v du. This is the model coming from integration by parts. Now, what's the meaning of u dv? Those are the two functions you are going to have in the question. For example, now let's say e.g. let's say if you have integral s exponential x dx, something like this. This one something like this. This one is u dv. That's what you're having there. Integral u dv. Now the first one is not u. The first one is not u. We can also have integral s squared exponential x dx. We can also have integral x log x to base e dx. We can also have integral s cos x dx and so on. Now, this is integral u dv. Now, the problem with this arrangement is that the first one is not always u. The first one can be u. The first one can also be dv. Now, if the first one is u, if the one, I will have 1, 2, it's only 2 dissimilar functions. Now, look at another thing. Out of these two, one of them will be u. We don't know the one that will be u. I'm not sure how to get the u out now. So what you have to do is to follow up. Then, if you can move out your u, the remaining one will now be dv. That will be the remaining one, not v. Now how do you get your u? Now to get u, look at what I'm going to do. To get u, because u is the only issue here. You can get your u, you're already good to go. Now if you cannot select the u well, you will not get answer in the question. You will be solving to infinity, you will not see any answer. To get your u or to obtain u or to select u, other use is the first thing you check if you have log x to base e. That's the first thing you check. If this one is not there, then you move to, you check if I have s raised power n there. If this one is not there, then you check if I have exponential s there. So if this one is not there, if these are not present in that place, it shows that that is not an integration by parts. So you can use another way to unravel that mystery if you can. So, or you just choose the one you like, but these are the ones you should take as your u. This will be your u in the question. Your u. So this is the first one, the second one, the third one. If this one is not there, you take this one. If this one is not there, you take this. So if you check this question, I will have s is power 1. S is there. It's s before exponential s. So we are going to take x. Let's have to select it. Do this and this. S square is there. S before this one. We're going to take this one. We do this and this one now. Log s is here. It's log s before this. We're going to take log s. But this one now, it is x before any other function. And this one, any other function may be possible. There's only s that is here now. We're going to take this s. Not cos x. This is the other use if you want to select your u. So let's solve this first one now. Integral x exponential x dx. So we said the u will be, there's no log x there. Is there s is power something here? We have s is power 1. That is x is power 1. We're going to take that as u. Then look at this formula. After we have select u dv, we have used v minus we have v du. What is not du? Now okay, du over dx. If you mention this s, what are going to have 1. So if you make the use of formula, you're going to have du to be equal to this one times this 1 dx or just dx. Then the other one, after you have selected the u out, you have gotten the du. Let's go v now. Let's get v. What is the v? The v will become the other function. If you remove this one, what will be left here? Exponential s ds. Exponential x dx. That will be our dv. Now to get v, you integrate this side, you also integrate this side. This will cancel this, only v will be left there. So v will be equal to integrate exponential s. It will remain as exponential s. It will not change. It will not change. It will remain as exponential x. So next thing, go to this formula and impute everything here. So we're going to have uv minus integral v du. So what is u? Our u was x. We have x. What is v? V was exponential x minus integral. What is v? Exponential x. What is the u? The u is 1 dx. The next thing we're going to have s exponential x minus exponential integral exponential 1 times ds will be of ds. So after everything now, we have substituted our something like terms, and we are having this now. So next thing, let's integrate what we have. Integrate exponential s ds. What do you have? We have s exponential x minus integrate exponential s ds. It will be exponential x. Then you have to integrate again. Integrate exponential x factor to s will be exponential x. There's no that again. We will see now. That will be the answer. Or you can say exponential x is common. Bring out to exponential x. We have s minus this one exponential x is going out. We have 1 there. Let's see. Let's run this. That's what I'm going to have. So this is how we do integration by part. First is select your u. Then, okay, let's look at this other one. So that this one I use one to explain also you get it. Integral s squared exponential x dx. So the first thing you do, you select out your u where u for this one, what is u? It is s before exponential x. So s will become the u. S squared is the u. Then the u will now be differentiate this one. We have 2x, then dx. That will be the u. The next, to get v now, we will now integrate the remaining one. That's how to get v. You integrate the one left. So if you integrate exponential x dx, without the one left, dx one left, that will be exponential x as well. So you go back to this place, you put the values there. So we have uv minus integral v du. So that will be uv, which is u is s squared, v is exponential x, minus integral v is exponential x times du is 2x dx. That's what I do have. So this will give us s squared exponential x minus integral. Let's move out 2 now. Let's move out that 2. Bring out the 2. We have x. Or if you may decide to just leave the 2 like that. If you move it out or you don't move it out, you get the same answer. I just we have 2x exponential x dx. That's what I have it. So we have to integrate 2x exponential x dx. We have s and x. You see how 2 things there. You have 2 things there. So if you decide to also move these 2 outside, you have x exponential x, which was what we did before, x exponential x, and we used integration by part to do it. So as far as these 2 terms that are here, that are having s, 2 functions of s that are there, you must integrate them using integration by part. So this person, you are still going to select, for this second one now, you select your u and your v. So let me put this 2 here. So our u there now will be this same function of s, which is 2x, then the u will be, differentiate 2x, you will have 2. Then v will now be integration of the other one, which is exponential x ds. That will be exponential x as well. That's how we do it. You must select your u using this order, then differentiate the u. Then v will now be when you integrate the remaining one. So this will give us, okay. Now what we are going to substitute, for this one, for this full question, what we are going to have here, to solve this one, what we are going to do, you see will be s squared exponential x, there's something here, minus, this one you still use this formula uv minus integral v du. Because this formula we use, we have to solve 2 terms that have function of s, we want to integrate them. So when you just substitute what we have into this piece, we're going to have s squared exponential x minus bracket u for this is 2x, v is exponential x minus integral v is exponential x, and then du is now 2 dx. So that's what we're going to have. Then this one give us s squared exponential x minus 2x exponential x minus, look at this 2 bracket exponential x dx. So the next thing now we're going to do, the next thing we're going to do here now will be, we have s squared exponential x minus, we have 2x exponential x, then 2, integrate exponential x, we're going to have exponential x, then plus c. If you integrate exponential x, we have exponential x, then see there's no other thing to integrate again, 2 plus c. This is how I don't integrate this one like this because there's no other thing there, we do have only one thing there. If I integrate only exponential x, then answer will remain as exponential x. So that's how it is done. So we put the bracket, we're going to have s squared exponential x minus times this, we're going to have minus 2x exponential x minus this one times this, minus times we're going to have plus 2 exponential x plus c. So that will be the answer to the question. Or you can say, we have exponential x everywhere. You can bring out that exponential x, bring out exponential x, that will be s squared minus 2x plus 2 plus c. So we're going to have as your answer. So we're going to have as your what? As your answer. Now, see how 2 questions here to solve. So take note of the 2 questions, we're still going to solve them. Take note of them. It's very important. Extremely important. So we're still going to solve those questions. We're still going to solve those questions. So just follow what we are doing here, and you are already good to go. You're already good to what? To go. So let's start. The next one is integral x log x to base e dx. For this one now, from that row I gave you, the first one is log x, and log x is here. So our u here now will be log x to base e. Then the u will be differentiate log x to base e 1 by x. And put the s at the back after everything. Then v will now be when you integrate the remaining one. If I remove log x to base e, what will be left here will be x and the x. I will left out. Then if you integrate s, you're going to have s 1 plus 1 all over 1 plus 1. Remember to integrate s polynomial function. Because s is power 1. You add up to this one and divide everything by that same power. Which is add 1 to 1, divide everything by that same thing. You're going to have s squared over 2. Remember that's how we do integrate polynomial functions. So we're going to have this. Now, going to the formula, our answer will be uv minus integral v dg. That's what we're going to have as our answer. So this will give us, uv minus integral v dg. uv minus what? Integral v dg. Integral what? Integral v dg. So the next thing now will be, let's go. Let's substitute. Use what? Log x to this e. V is x squared over 2 minus integral v is what? S squared over 2. Then du is 1 over s dx. 1 over s what? Yes. So the next thing we're going to have will be, the next thing we'll be having here will be s cancel 1 of this x. So 1 over 2 will go outside. Got it? 1 over 2 will go out. So we'll be having this one now. Log s to base times s squared over 2. This s squared over 2 will go up. This log cannot multiply this, but they are not the same thing. So we're going to have s squared over 2 log x to base e minus integral 1 over 2 will move outside. So we're going to have 1 over 2 integral x then dx. 1 over 2 is going to have only s then dx. So if you integrate s ds, remember if you integrate s ds, remember it's s over 1. We don't manipulate if it's 1. So we're going to have s squared over 2 log x to be c minus 1 over 2. Integrate this now, we're going to have s squared over 2 plus c. So if you check, we have s squared over 2 here, we have s squared over 2 here. You can move it out, we have s squared over 2 here and here in brackets. What we left here? Log x to base e. And what we left here? 1 over 2 plus c. This is what we have here. Then the third one was integral. What is it called? Integral s cos x dx. S cos x dx. So remember our u is what? X. The u will be 1 dx. When we differentiate this one, I'm going to have 1 dx. The v will be integration of the other side is cos s ds. If you integrate cos s, what am I going to have? Integrate cos s, what am I going to have? If you integrate cos s, you're going to have sin x. That's what you're going to have. If you integrate cos s, you have sin x. So you have something very nice there, a very lovely something. So this will give us the answer will be uv minus integral v dg. uv minus integral v dg. What is u? X. What is v? Sin x minus integral v sin x. And d is what? 1 dx. So from here now we have x sin x minus integral sin x dx. So that gives us x sin x minus integrate sin s ds. What are we going to have? If you integrate sin s ds, what will we be having there? If I integrate sin s ds, I'll be having minus cos x plus c. If you integrate sin s, respect to this, you have minus cos s plus c. We have done that. So we're going to have lastly s sin x minus times minus to give us plus cos x plus c. Answer. That is what we are going to have. So let's look at shortcuts. Alright, remember the question was integral s cos x dx. Remember, we already have the topic under this integration by part 2. You can go back and look at the topic again after this one. So if you want to do shortcut, look at shortcut. First of all, identify your u first. Then to get the v, I already told you how to do, integrate the other side. Which one between s and cos s, which one will be the u? Cos and sine can never be u self. You don't take cheap functions as u. You only take either exponential function, logarithmic function, or polynomial. If logarithmic function is the first one, if there's no log there, you take s. If there's no, it's a direct exponential function. So this one now, we have s over something here. So you just take this one as u. So you write out that u. Then you now integrate the other one. Integrate this one. Integrate cos x. I'm going to have sin x. Then you are done with that question. Then from that formula, the next thing is minus, then you come. Then you will start integrating the v and you will be differentiating the u. Remember the u was the x, then this other one was the v. V is when you integrate the other part, that will give you v. Now, differentiate this one, you have 1 times integrate sin x, you have minus cos x. Then, if you differentiate this one, it will be 0, then you stop. Remember that your u have been reduced to a constant, so that if you differentiate it becomes 0, you stop. Then, r plus c. Automatically, the answer will be x sin x minus times minus plus 1 times cos s plus c. Answer. It's as simple as that. Very, very simple as that. Look at it. Let's see what happens like this. Let's see another one. S3. Let me use cos as well. Cos x dx. What you do? First of all, choose u. U is s cubed. Write down that. Then the other one, we integrate it to get v. Integration I'm going to have sin x. Then you are done with this. You come back to this. Then you start differentiating your u and you'll be integrating your v. Differentiate this one minus, the first one will be minus. Differentiate this one, you have 3s squared. Then integrate this one, you have minus cos x. You close it. Differentiate this one now. Now, if you use minus for this first one, the next term you are going to write, you use plus. The signs between terms will be alternating. If you use minus for this first one, the next term will be plus, next one will be minus, the next one will be plus, and so on. It will be alternating. The signs will be alternating. Also take note of that. Then you use plus now. Differentiate this one, we're going to have 6x. Integrate one, and you're going to have minus sine x. You close it. Then minus again. I use plus and use minus. Differentiate this one, you have 6. Integrate this one, you have minus plus s. Minus will be plus. Supposed to be minus. Integrate one, you have minus cos x. Then differentiation will be 0 plus 2. Since you differentiate 6 will be 0. Then you start to finish everything. I have s cubed sin x minus times minus plus 3x squared cos x. Then this one minus times plus minus 6x sin x. Then plus minus times minus plus minus 6 cos x plus c. That becomes the answer. So, lastly, we can do this integral x exponential x. Let me use s squared. Which one is v here? Which one is v here? Which one is v here? The v is what? Which one is, there's no v dx. There's no v. V is when you have choosing your u, then you now integrate the other one to get v. Which one is u between this? U is what? S squared. It's not, the first one is not u. The procedure I gave you, that is the procedure to picking u. Log first. If there's no log, then you take s for something, or you take exponential x. Then to get v now, you integrate exponential x, you exponential x. Then minus. Then you start with the differentiate 2x, you have 2x. Integrate 1, you have exponential x as well. Then plus, take minus, take plus now. Differentiate 2x, you have 2. Integrate 1, you have exponential x. Then minus, differentiate this one, 0. There's no need of doing it again. If you differentiate the u and becomes 0, you stop. You add plus c. So give us exponential, you come out. Since they are common, you have s squared left, 2s left, and 2 left. Answer. This is how we run this. Thank you.
Alright, take note of this. The shortcut won't work for any integration by parts that has log x to base e, or the combination of both exponential function and trig function. For now, the shortcut won't work very well for things like this. Anything like exponential function and trig, it will not work like these two questions now. Then anything that has this log x to base e, it will not still work. So please take note of that. It's very, very important.
Alright, now let's look at the case of integration of this type. We have exponential x and trig function. How do you do it? Exponential x and trig function. This one is a very special type. we combine the exponential s and three equations together. Now remember the use here is what? Exponential s. Shortcut cannot run this for now. Then the u will be exponential s ds. So we differentiate exponential s to be the same thing. V will be integrating the other side. Integral sine x dx. That will be minus cos x. Supposed to have plus c, but don't do it because you are still working. Then from this formula, uv minus integral v du, you have something like this. U is what? Exponential s. V is what? Minus cos x minus integral minus cos x. ds is what? Exponential s ds, s du. Du is exponential s dx. So the next thing I'm going to do now, let's write everything. Now minus exponential s cos x minus exponential s cos x. Then but you bring this minus out. Minus equals plus integral exponential x cos x dx. You see? If you have another thing, let me integrate. We have something like, look at this. I'm going to use this one there. We use integration by parts. You see how exponential s cos s. Because we have exponential s and s here. Let's go. This one will still be this. We still take this shape. So take this shape. We have something like this here. And will still be minus exponential s cos s plus this one will still be uv minus integral v du. This is the formula for integrating anything that have two things like this, which is a product function. So, and they are similar. So, to do that now, we are going to s cos x plus, now which one is u here? U is exponential x. Then v will be one integrate this one. Integrate sin cos x. What do you have? You have sin x minus integral sin x exponential x. The u is going to differentiate that your u. Differentiate this one, you have exponential s dx. Exponential s dx. That's what I'm going to have. See, it is still going. Exponential x cos x plus exponential x sin x. Exponential s sin x. Exponential sin x. Then minus integral exponential x sin s dx. That's what we have. But there's a problem here. And what is the problem? The problem is the thing will keep on being 2. We keep on solving until we'll be tired. So what do? We discover that if you have exponential s and trig function, after you have integrated 2 times, you have done the first one, the second one, you discover that this last term will be equal to the question. Check this question. Check this one. This is the question we are solving. Check what you have here. If they are not the same, check. Are they not the same thing? Check. This integral exponential s sin s ds. Integral exponential s sin s ds. So since they are not the same, that's okay. Therefore, let the question integral exponential s sin s ds be equal to I. So you see, let the question be equal to I, so that the question itself, which is I, will now be minus exponential s cos x plus exponential x sin s minus, this one is still the question. I'm saying that now be I, but that's still the question. So that I will now be exponential s cos x plus, open everything, remain the same, exponential s sin x minus I. I will come to this side. We have I plus I is equals to minus exponential s cos x plus exponential s sin x. The next thing, I plus I is 2i. So we have 2i. We have 2i. We're going to solve it algebra as we are doing like what we do in algebra. Simple equation. Just find the unknown. The unknown is I. That's what I'm trying to do now. Just find unknown out. You have minus exponential s cos x plus exponential x sin x. Next, divided by 2. So by 2, can cancel this. Then the I will now becomes. Remember, we can even change this one. We can write something called this minus. We can say plus this minus this. We can do it like that now. Or move back exponential. Move back the exponential this thing, exponential x. We can just write this one before this. You see, sine x minus cos x. You can do it like that. You can also say minus cos s plus sine s. You are still correct. You can also see exponential x equal to minus cos s plus sine s. You are still good to go. So this is how we do this for trig function. Over integrate the first time, integrate it again, then you now call your question I. But this one, the question will be showing here after you have integrated the second time. Then find that value of I. That will become the answer. That's how we do this. Remember the shortcut we did? The shortcut is for x and exponential, s and trig. That's what we use the shortcut for. S and exponential, s and trig. X and log do not work. Exponential and trig should also work. So remember, we found the shape of something now. Before right hand on you, we integrate the other one to get your v. Next, you take minus, take your minus, and write this now. Differentiate this one, you have minus 1. Integrate this one, you have sine x. So I go to half. So the next thing, differentiate one, that will be plus c. That will give us minus x plus sine x plus c. That becomes the answer. Just stop there. That becomes the answer. The final answer. So please take note of this shortcut. After you pick out the integrate the other one to get this, then you start differentiating this and you integrate this. Differentiate minus s, you have minus 1. Integrate this one, you have sine x. The next thing, division of the 0, you have plus c. Just to verify everything, you get your final answer. So thank you all. God bless you. I'll see you guys in our next class. Thank you. God bless you.